Hi everyone, we're going to use the binomial series to expand the function as a power series and also state the radius of convergence. We have 1 divided by 2 plus x cubed. So we want to write it in this format here. You can see that. So that's 1 plus x to the power of k. So what I'm going to do is take my function here and write this as 1 divided by 2 times 1 plus x divided by 2 cubed. Now this is going to simplify. If I pull 2 cube out, this is going to be 1/8, and then I'm going to have 1 plus x divided by 2 to the power of -3. So since I have that, I can write it as this form: 1/8 times the sum as n equals 0 to infinity, and my k is going to be -3n, and then my x part is going to be x divided by 2 to the power of n. Now, I think for this one, let's just go ahead and look and see what this is. -3, choose n. Now, if you expand that, you're going to get -3 times -4 times -5 times and so on. And then for the pattern, that would be -3 minus n plus 1. Because we keep adding it, since we're starting at 0, we have to add the plus 1. Now this is really -n minus 2 here. Okay, so I can write, and this is all over in factorial. So I can write this as -3 times -4 times -5 ... And then for this, I'm going to write this part here as negative n plus 2, because that's what these are all equivalent, all divided by n factorial. Now, the next step I'm going to do is I'm going to pull out -1 to the nth power, and I'm also going to add another term. So I have this term, and if I add another term, that's what it's going to look like this. I'm going to get -1 to the nth, and I'm going to put times 2, and my denominator is n factorial. But since I'm adding a 2 here, I'm going to put a 2 there as well. So I'm just multiplying the numerator and denominator by 2. So that's going to be times 3 times 4 times 5 times ... And with the new term, this is going to be n plus 1. And we already had our n plus 2. So let's put n plus 2. All right. Now, from there, I can simplify this, because this right here is just n factorial. So I can write this now as -1 to the nth power and cross these out. And I'm going to get n plus 1 times n plus 2, all divided by 2. All right, now I have to go back to my sum that I had previously, because all we were dealing with now is the binomial coefficient part. So let's do that. And we're going to have our, this part here equals 1/8 times the sum from n equals 0 to infinity. And we had -1 to the nth power times n plus 1 times n plus 2, all divided by 2. And now we have to multiply it by our x, which was x to the nth power divided by 2 to the nth power. I just broke that up. All right. So for the denominator, we're going to get, let's see, we have the 1/8. So let's just write this as the sum. N equals 0 to infinity. My numerator is going to be -1 times n plus 1 times n plus 2. And I'm going to pull this out as x to the power of n. Now for my denominator, I have this 8. So let's do this on the side. This is going to give me 8 times 2 times 2 to the nth power. So this is really 2 cubed times 2 times 2 to the nth. So we have, this is to the first power. So this is going to be 2 to the nth plus 3 plus 1, which equals 2 to the power of n plus 4. So this is your final answer here. And also we have to do the radius of convergence. Remember we had, where is it? We had this 1 plus x divided by 2 to the power of negative 3. So we're looking at this. So you take the absolute value of x divided by 2. For it to be convergent, it has to be less than 1. So you cross multiply, you get absolute value of x is less than 2. So your radius of convergence equals 2. Thank you. Have a nice day. Bye-bye.